All right, so we want to look at Chapter 4, review problem number 6. This problem says that 38% of likely U.S. voters think the federal government should get more involved in fighting local crime. You randomly select 6 likely U.S. voters and ask them whether they think that the federal government should get more involved in fighting local crime. The random variables represent the number of likely U.S. voters who think that the federal government should get more involved in fighting local crime. So things to look at from this is we have a chance of success, which is 38%. We have a fixed trial size, which is 6, and we're looking for the distribution within that. This is a binomial distribution. The question does say, hey, what is the mean of the binomial distribution? What's the variance and what's the standard deviation? And then it asks at the end, hey, in most samples of 6 U.S. voters, the number of voters who think the federal government should get more involved in local crime would differ from the mean by no more than. So this kind of links all of the things into this distribution together. So let's look at what we can get from this here. So our probability of success is 0.38. That means the probability of failure has to add up to 1, or 0.62. And our number of trials are 6. Now, for all of the useful information it's asking for, we have that the mean is going to be the number of trials times the probability of success. The variance is going to be the number of trials times the probability of success times the probability of failure. And if we note here, we can also say it's the mean times the probability of failure. And the standard deviation is the square root of this value. And it asks for everything rounded to the nearest tenth or 1 decimal place. So to find the calculate the mean, we'll take 6 times 0.38, which equals 2.28, or approximately 2.3. To find the variance, we'll take that mean and multiply it by the chance of failure. Which gives us 1.4136, or approximately 1.4. I'm sorry, 1.426. Still approximately 1.4. And if we take the square root of this, 1.426, we get 1.194, and so on, which is approximately 1.2. So we use these formulae to calculate our useful variables. But the meaning from this, and how we will sometimes write this, is that, well, back in Chapter 2, and we looked at standard deviations, and we said, hey, if I have a mean, and I go plus 1 standard deviation and minus 1 standard deviation, 68% of the population's in between that. Well, 68% of the population is going to be a good word for most, or a good numerical value for most. And so that last question saying, what can we say? Well, we can say that 2.3 plus or minus 1.2 is most of the results.